Hello everybody and welcome back to another episode of Science with Mr. Emond. Today we're going to be finishing up our unit on aqueous solutions. We're going to be looking at an extension of our KSP, our solubility product constant today, but we're going to be doing so in a way that's going to kind of use Le Chatelier's principle, and we're going to be investigating what happens when you add in a common ion. When you add in a common ion, you start to see the common ion effect. And as you can probably gauge by this picture here, if I add in a common ion into a solution that's already in equilibrium, we're going to start to get these little crystals that form. These little crystals showing us that we have formed a precipitate. So let's go ahead and start to investigate this. The common ion effect is it's an example of how Le Chatelier's principle can influence the solubility of an ionic compound. It states that the solubility of an ionic compound is decreased by the addition of a common ion. So if you add in a common ion, the solubility of your original ionic compound is going to decrease. Common ions, they come by adding another ionic compound to the solution that contains one of the ions that were already present in that solution. If it was already present, it means the ion's in common. All right, let's go ahead and try this. And when we try this, you're going to notice how similar to Le Chatelier's principle this is. Let's look at this first example. If barium sulfate is in an equilibrium solution. If it's in an equilibrium solution, then that means that it's completely saturated. So it's at its saturation point. And if barium sulfate was in an equilibrium solution, then that means that it is going to be full of barium 2+ ions and sulfate 2- ions. That is how barium sulfate dissociates. Well, let's ask ourselves, if we have barium sulfate that's in equilibrium, what would happen if we added barium chloride? So barium chloride is BaCl2. And when BaCl2, if we add this in to our beaker, so let's say here we have our beaker, there it is, and it's full of a solution, and we have barium 2+ ions, and we have sulfate ions. And these ions are completely dissolved in this solution. There's no solid here, but we know that if we add any more, there's going to be too many ions, and those ions are going to precipitate. They're going to form a solid. Well, what happens if we put in this beaker? We're going to pour into this beaker a liquid, and in this liquid, we have what? When barium chloride dissociates, we get barium 2+ and chlorine. Well, interestingly enough, we already had barium 2+. That was our purple dots. This barium is in common. So if I add more barium into this beaker, what did we say is going to happen? It's going to precipitate. Now, we're also adding chlorine ions, right? Do the chlorine ions matter when I add them into this beaker, these little green dots? No, not really, because they're not in common. Adding in chlorine is not going to affect my original system, is it? It's not going to impact it at all. By adding barium, though, now we have too much barium. Let's do some predictions as to what's going to happen using Le Chatelier's principle. Le Chatelier's principle states that if we add stress to a system in equilibrium, this is my system in equilibrium. The stress is I added in barium 2+ when I added this liquid. By adding in barium 2+, I've created stress on my equilibrium system. Le Chatelier's principle says that when a stress is added to a system in equilibrium, the system will do what's necessary to relieve itself of that stress. If the stress is there's too much barium, how is Le Chatelier's principle going to predict that we get rid of that stress? By getting rid of the barium. Decrease it. If there's too much, get rid of it. If we get rid of barium, then we also have to get rid of the sulfate. Why? Because these two things are going to join together. That's what this plus sign means. They're going to join together to create barium sulfate. Notice which direction my overall arrow went. It went to the left. This is an equilibrium shift to the left. Let's look at what we had here. The common ion is barium 2+. We knew that. We saw it. According to Le Chatelier's principle, if we add in a new source of barium 2+, that means that the barium concentration will increase. That's the stress. What will the equilibrium system try to do? Get rid of barium, shifting it to the left, or the reverse reaction. If we shift to the left, then what are we going to create? Barium sulfate. If more barium sulfate is produced, then the concentration of barium sulfate is going to go up. Now, in the previous slide, we said that if adding a common ion is going to cause the solubility to decrease. If we have more barium sulfate solid that gets formed, because this is going to precipitate out, if this is formed, then our solubility will decrease. Because the more barium sulfate there is, the less barium sulfate you're going to be able to add and dissolve into solution. So if there's more barium sulfate than before, then the solubility of barium sulfate will decrease. Why? Because there's more solid now. And because there's more solid now, less can be dissolved. So that's how you need to approach these problems. Now, this is going to be an interesting case. Every once in a while, you're going to need to consider if when you add a substance, if it's going to create a precipitate that was already in your equilibrium expression, or if it's going to create an additional precipitate. If it adds a brand new precipitate into your mix, then the ions that make that precipitate are no longer able to be used in your original system. So the ions from the original system are going to drop out. If those ions can't be used, then that means we can make more of the solid that came in that original system. So the solubility will go up. Let's try our understanding out. We're going to look at what would happen to the solubility of sodium sulfate. Now remember, sodium sulfate is Na2SO4. What would happen to the solubility of sodium sulfate if we added the following? If we added sodium chloride, sulfuric acid, and calcium hydroxide. Now we're not adding them in all at once. These are 3 different problems that we're going to investigate one at a time. Let's start with sodium chloride. If we add in sodium chloride into our sodium sulfate that's in equilibrium, what's going to happen? Well, first let's dissociate sodium sulfate. So this is our equilibrium system. We have sodium sulfate dissociating into sodium ions and sulfate ions. If we add in NaCl, what's going to happen? Well, let's see what NaCl dissociates into. It dissociates into 1 Na plus and 1 Cl minus. Is there a common ion? There certainly is a common ion. What is the common ion? Sodium. Notice that sodium is in common between these two dissociation equations. What does this mean? What it means is if by adding sodium chloride we get more sodium ions, then down here there's going to be more sodium ions that are available to react in our original equation. That's a stress. If the stress is that there's too much sodium, what are we going to try to do? Get rid of the sodium. In order to get rid of the sodium, we're going to have to use it. Use it up with sulfate. When we use up the sulfate, it too will go down. And this is going to cause an overall shift. When we use sodium and sulfate, what are they going to create? They're going to create sodium sulfate. So this is a shift to the left. We're going to use these two things, and we're going to create sodium sulfate. Let's check our progress so far. The common ion is sodium. Yes. It's an equilibrium shift to the left. Yes. What does that mean is going to happen to my concentration of sodium sulfate? Well, by creating sodium sulfate, its concentration will go up. So more sodium sulfate's produced, so its concentration goes up. Now, we said before, if there's more sodium sulfate, then the solubility will go down. So the solubility will decrease. Why? Because more solid's present. If there's more solid, it's going to be harder to dissolve things. So its solubility will go down. All right. Why don't you give this one a shot? Pause the video. Think this through. What happens when you add H2SO4? When you think you have the solution, come back and let's check it out together. All right. Welcome back. Let's take a look at this. So Na2SO4, we already know, dissociates into this. What happens when you add sulfuric acid? What does sulfuric acid dissociate into? Well, it dissociates into two H pluses and one SO4 2 minus. Is there a common ion here? There is. What's the common ion? Sulfate. So hopefully you got that first part. The common ion is sulfate. If we're adding in sulfate, that means that this concentration is going up. That's the stress. So what's the reaction going to try to do? Decrease it. And we're going to use these two things to shift it to the left. This means we're creating sodium sulfate. So sodium sulfate's concentration will go up. If sodium sulfate's concentration goes up, that means we're going to decrease solubility. And why? Because there's more solid, so it's harder to dissolve. All right. This is going to be the icing on the cake, the last problem, the hardest problem. This is going to be our special case that we talked about here, where what happens if when you add something in, it creates a brand new precipitate? Let's look at that. Before I show you what to do, let's see if you're one of those students that's bright enough to figure it out on your own. Can you make this prediction? Try it out. Pause the video and come back if you think you know what's going to happen. See you soon. All right. Welcome back. Let's test your predictive capacity. What happens to our system in equilibrium if we add calcium hydroxide? What is this going to dissociate into? Well, this is going to dissociate into 1 Ca2 plus and 2 OH minuses. Let's compare. Is there any common ions here? No. There are no common ions. You got a sneak peek. There is a precipitate that's going to form though. When I think about my beaker, I now have 4 things in here. I have calcium, 2+, I have OH-, I have sodium+, and I have sulfate, 2-. All 4 of these things are in my beaker. They're all mixing together. When they mix together, will the calcium and the sulfate make a new compound? It will. That's going to be CaSO4. And if I check this compound on my solubility table, it's a solid. This new precipitate formed between calcium and sulfate is a solid. So what's going to happen in this case? Well, if I am going to be using calcium and using sulfate, remember, I'm only interested when I'm doing these in my original equation. If what's happening is I'm using the sulfate to create CaSO4, that's a stress, because some of this sulfate that should be in this original equilibrium is getting used. That's a stress. I'm going to want to get more of it because I'm losing it. I want to make more. In order to make more sulfate, I'm going to have to take this Na2SO4 in order to create more SO4. And in the process, I'm also going to create more sodium positive ions, right? This is a shift to the right. Shift to the right. What happens then to my concentration of sodium sulfate? Well, it's going to go down because I'm using it to make more sulfate, because I lost the sulfate to make calcium sulfate. Well, if my concentration goes down, then my solubility goes up. So the formation of calcium sulfate, that precipitate, this solid, sucks up the sulfate ions. We're using them out of our original equation, allowing it to dissolve more easily. And that means that our solubility is going to increase. Why? Because more solids now able to dissolve. There's room for more because we've lost some concentration. All right, there you go, the common ion effect. It's basically Le Chatelier's principle all over again. Hope you enjoyed this video and learned something. See you next time. Keep learning, everybody. Bye-bye.
Hey everybody, you can like, follow, and subscribe to my social medias right here to get notifications as soon as new content is uploaded. This video concludes our learning unit. You can find the playlist this video was in right here and click here for the next unit that we'll be covering. Thanks for watching and keep learning, everybody. Bye-bye.